I wanted to see how far I could push drawing with a single line. The answer is apparently way too far. See, I've been enjoying hand drawing technical diagrams. The results are satisfying, but they take forever. I originally built this machine to help me out. Then I got carried away. Once I saw what it could do, I became obsessed. How much detail? How much shading? How much realism can emerge from a single, unbroken stroke? So what actually is drawing? Mechanically, it's surprisingly simple. You hold a pen, and you move it across a surface. To do that, we need two independent axes of motion. We need high accuracy, and collaboration, so I can draw with the machine.
What is the radius? I meant the diameter. Oh.
And collaboration, so I can draw with the machine. A Cartesian plotter solves the accuracy problem, but not the collaboration problem. This polar plotter from a previous video lets me hold the pen, but it's just not accurate enough. This design combines the best of both. The pen can move anywhere in the 2D plane, and there's plenty of space for me on this side to hold the pen. So I started manufacturing parts. Let's start with the x-axis. This rail handles all horizontal motion. If I push at the end of a long arm attached here, the slide will want to twist and lock up. So I'm using two slides and spacing them as far as possible. The y-axis needs to be lightweight but still rigid, so it rides on these rods and linear bearings.
Oh.
And the pen just friction fits into the end effector here. Then we hit our first major problem. While the y-axis is gliding smoothly, there's a lot more friction in the x-axis. So I redesigned the entire x-axis to instead also run on a linear bearing. Now it's time to bring this machine to life. Timing belts let the system move quickly without sacrificing precision. We'll get this powered in just a second, but first a quick word from the sponsor. One thing that always surprises me about these build projects is how much time disappears into sourcing parts. The bearings, linear rails, shafts, pulleys, all the little mechanical components that make this machine possible. That's actually why I've been using JLCMC lately. Most people know JLC for their PCBs, but they also have a pretty extensive catalog of mechanical and motion control components. So instead of ordering electronics from one place, bearings from another, and linear motion parts from a third, I can usually get everything for a project in a single order. Pricing is really quite good depending on your shipping option, and honestly, having fewer suppliers to manage just makes the projects easier. So if you also have a build project that requires mechatronic components, I've put a link to JLCMC in the description if you'd like to take a look. Now let's get back to the build. I'll control everything with an Arduino and two stepper drivers, which means it's finally time for the moment of truth.
Oh, duh.
What? Alright, that should do it.
There it is.
There we go. Now that the machine can move, it's finally time to make some marks. Small problem though. When the arm retracts, there's more weight behind the pivot than in front of it, which means the pen lifts off the page. I'm going to solve this one using the highest level of engineering sophistication. Bubble wrap. Now we get good contact. Straight lines are easy, but how do we draw something curved? These motors move in tiny discrete steps. At each step, I can move the x-axis, the y-axis, or both. By combining these, we can approximate any angle we want. Worried about these bumps? Each step is 10 micrometers, so a full millimeter would look like this. Oh, and the line of ink from the pen is this thick. We can break down curved shapes into a bunch of tiny line segments, and suddenly the machine can draw smooth shapes. And look how precise it is as I tell it to draw the exact same circle twice. We're ready to compare man versus machine. And honestly, it's not even close. With this device, I don't have to move my ruler, and I don't have to adjust my angle. I don't even have to measure distance. I just use my number pad to select a line direction, type the distance, and the machine does the rest. So suddenly, a drawing that would normally take forever becomes almost effortless. But these rigid drawings don't even scratch the surface of what this machine can do.
It's time to start pushing the limits of where we can go with a single line drawing.
The first place my mind goes is calligraphy. It's beautiful, it's continuous, and it's distinctly human.
Cursive writing has so much personality that it's notoriously difficult to forge, so it should be completely impossible for this machine.
I need a way to try to digitize letters. So I wrote a program that lets me trace curves and export them as coordinates. Now the machine can try writing. Maybe slightly scaled down. That should also make the corners less obvious. I need to make sure every letter begins and ends at the same height.
Let's think. What other words can we write? Maybe Rockefeller's signature. With any luck, I will be retiring shortly.
I added a simple connector stroke for spaces, and suddenly this machine has made another jump in capability, writing complete lines of text. But there's still one problem. How do you move down the page without breaking the line? My elegant and maybe completely bizarre solution is to write every other line backwards. With punctuation added, the machine can write full pages, and at this point, things start to get a bit surreal. This machine that a minute ago could only draw straight lines and circles is now effortlessly writing the first page of The Wizard of Oz.
I want to push even further, not just writing, but actual drawings. The only problem is, I have no idea how.
Now I could just trace a drawing like we did for the letters. But we did that already. We need a different approach. Every digital image is just a grid of pixels. For grayscale images, there's simply bright pixels, dark pixels, and shades in between. And somehow, that's enough to create realism. So if I move through the image one pixel at a time, all I really need is some way to represent brightness. ASCII characters work, burnt toast works, apparently anything can become an image.
But what can we do with a single, unbroken line?
Writing back and forth in cursive gave me an idea. What if the machine drew a sine wave across each row of pixels? And every time it enters a new pixel, the amplitude changes to match the brightness. So in theory, we should be able to trick our eye into seeing an image, when really, it's just a bunch of squiggles.
But this is all just theory. Could it actually work?
Let's put it to the test. Thanks to all that time programming, it actually ran surprisingly well. From far away, that genuinely looks like the Mona Lisa. But there are definitely problems. Plus, it took a really long time, even though the resolution isn't even good. So I pushed the machine harder. Higher speed, more detail. Which immediately caused problems with the motor's skipping steps. So I tuned the variables. We've had some cool results so far, but this is the first one that genuinely shocked me. There is absolutely no ambiguity. Instead of scanning row by row, what if we spiraled outward from the center? As the spiral expands, the machine zigzags around the ideal path to encode brightness. I was impressed before with the Home Alone image. Now I'm starting to get creeped out. This looks exactly like Einstein. I can't push the detail any higher without the image turning to mud. So I swapped the marker for a much finer ballpoint pen. This lets me push the resolution and the frequency even higher. And at this point, something strange happened. The illusion became so convincing that I basically stopped seeing this as a drawing robot, and it started to feel like a printer. My brain just started accepting them as normal.
If we're gonna do this, let's really do this. We're adding color.
There's no way I'm loading hundreds of markers onto this machine, but luckily we can hack human vision. Our eyes only actually have receptors for blue, red, and green light. It's by mixing these that we get millions of color combinations. Screens create color by creating light, but markers work by absorbing light. So instead of red, green, and blue, we need their opposites, cyan, magenta, and yellow. This is actually the same trick used in printing old comics. Tiny colored dots that your brain blends together into full color. So let's go ahead and decompose this image into yellow, magenta, and cyan channels. I still need to add the final black layer, but no, this ain't it. That's very yellow. I think I know the problem. These water-based markers just layer on top of each other instead of mixing. Switching to these alcohol markers should blend much better. So I redid the color lines with the new markers, and now we're ready to add the black, which leads us to our final drawing. Wow, just wow. I genuinely did not think that this would work that well. I mean, that's the freaking Mona Lisa. And there's one mess up with the yellow, but that hardly matters. And yes, each color is its own line. But come on. And I like that it not only looks cool from far away, it maybe even looks cooler zoomed in. This machine was originally just supposed to help me draw straight lines. And somehow it turned into a machine that can draw photorealistic images, using nothing but squiggles. Alright, that's all for today's video. Thanks so much for watching. If you like this kind of content, be sure to subscribe, and I'll see you next time.